फ्रेंड्स, आज हम स्टडी करेंगे पिनाकोल के रिएक्शंस के स्पेशल फीचर्स. अप टू दिस टाइम वी हैव स्टडीड अबाउट pinacol rearrangement, molecular rearrangement and its mechanism. Now we will study about special features. There are five special features. First is stability of carbonium ion. What is this? In this, if there are possibilities of formation of two carbonium ions, then which will be stable, then that carbonium ion will be formed. Yes, in this case, as such, this is the compound. There are two ways of formation of carbonium ion. If this hydroxy group will remove, then this carbonium ion 1 will produce. If this one hydroxy group will remove, then this carbonium ion will produce. Now competition between these two, which one will produce? Out of these, this will produce carbonium ion 2 is stable in comparison to 1, because in this there are two phenyl groups. So this carbonium ion can be stabilized by resonance on phenyl group. Whereas in this is not possible. Therefore, this carbonium ion will produce in the reaction and product will be according to this. Second is migratory aptitude of the group. What is the migratory aptitude of the group? It is the easiness which favor the migration of group. That group will migrate, which will favor the easiness to attack on carbonium ion in case of this pinacol reaction. Because, for example, in this compound, there are comparison between three groups: proton, hydrogen, methyl group and phenyl group, which will migrate. In this case, hydrogen will migrate. Migration of hydrogen. First of all, OH will remove from here. OH will remove from here. Carbonium ion will produce, and hydrogen will migrate in place of methyl. So there is a competition between hydrogen and methyl group. So hydrogen will migrate and product will be less. Similarly, in this case, competition between methyl group and phenyl group. Which will migrate? In this, phenyl group migrate. OH will remove from here. Carbonium ion produce. Now, competition between these two, methyl group and phenyl group. Phenyl group will migrate because it can easily provide electrons to the carbonium ion. Therefore, this product will be formed. So, migration of phenyl group. इसी तरह, if there are different aryl groups, in them the migratory aptitude of para-anisile is highest, then para-toluene, then phenyl, and then ortho-anisile. That is, ortho-anisile is lowest in migratory aptitude. Next is steric factor. Steric factor. What is steric factor? If compound is sterically hindered, migratory group is sterically hindered, then its migratory aptitude will be less and its reaction will be low. As in case of para-anisile and ortho-anisile, both having the same group. Para-anisile means this. पैरा पोजीशन पर O मिथाइल है ना. ऑर्थो मीन्स यहाँ पर O मिथाइल. This is ortho-anisile, this is para-anisile. Because in this para-anisile, methoxy group is at para position, that is far away from the migrating point. In this, O methyl group is nearer to the migrating group. So in this steric hindrance, therefore due to the steric hindrance, ortho faster reaction than ortho-NSL, or we can say para-NSL group will migrate 100 times faster than that of ortho-NSL. Last है transmigration. Transmigration क्या होता है? What is transmigration? Transmigration is whenever OH group is removed, then any group migrate to that carbonium ion. Then that group will migrate, which will be at trans position. The beautiful example of this is 1,2-dihydroxy 1,2-dimethyl cyclohexene. This is the compound. This compound can exist in two forms, cis form and trans form. cis form में क्या है? In this देखो, this OH group will remove carbonium ion will produce, and then because this methyl group at second position is in trans to this leaving OH group, will migrate to this carbon. यहाँ से this along with its electrons, it will migrate to this, and the product will be finally this 2,2-dimethyl cyclohexanone. Whereas in case of trans derivative मतलब trans 1,2-dihydroxy 1,2-dimethyl cyclohexane. This is the trans derivative. In this, because OH leaving group, methyl group migrating, these two are not in trans position. These are in cis position. Therefore, migration of methyl group at the carbonium ion produced by the evolution of this OH will not migrate to this point. And in place of this, we get 1-acetyl, 1-methyl cyclopentanone, or we can say suppression of the ring size. This methyl group, this CH2, this will migrate to this in place of methyl. From here, OH removed, carbonium ion will produce. Carbonium ion produced, then this methyl group will not migrate because this is not in transposition to this OH group. Therefore, this CH2 ring, जो CH2 है, that will migrate to this, and it will produce this pentanone. In place of hexane, it will convert to pentane, cyclopentane ring, and the product will be 1-acetyl, 1-methyl cyclopentanone. So this is the trans effect. Fifth one is intramolecular migration, which we have already studied. Intramolecular migration, the migratory group never leave the proximity of the molecule. Therefore, that one is known as intramolecular, which we have studied previously.